Right, okay, I just want to talk about the even number questions that I said to do. So here's the answers really. Yeah, so that's number 2. There wasn't much to say about this really, apart from when I was doing this integration here. I just done it by substitution because I like doing integration by substitution. Came out nice, but you could have done it by reverse chain rule, obviously. But I do like integration by substitution. And then after that, it was pretty straightforward. So that was question 2. And then question 4. There's not much to say about that either, really, apart from it struck me as a bit unusual, to be honest. The beginning of it, I don't know, but just divided both sides by this, and then you end up with this, which you integrate, and then substitute into find C. And I just quite enjoyed this, this messing around with these little logs. And that's just to get actually the subject of the formula. So that was question 4. Question 6, we did one identical to question 6. Well, identical. I don't think it was identical, but very similar anyway. In class before we talked about all this, but yeah, it's 7's the one. Like 7's tough, and 7's what in my opinion would be most likely to be on an exam, but also to be useful. Okay, so I'll tell you what, right? Questions like this, and these remind me of the normal A-level questions, where I'm talking about, sort of chain rule type questions where you have like dv was ds and ds was dt and stuff like that. I like to draw a picture anyway, so it's not a boss picture, but just in terms of just to sort my own thinking out. So I'm going to draw a picture of the storage tank. I don't really know what one looks like, but just like that. Starts off with 500 inside it, and then what's going on? What is the 50 centimeters cubed per hour is going in. Oh, is that gone off the screen? Yeah. Yes. 50 centimeters cubed per hour is going in, and it's 5% oxygen and 95% helium. Yeah, I'm just trying to write that is 2.5 of oxygen and 95%, what's that, 47.5 then of helium. So that's what's going in, and then coming out is 20 centimeters cubed per hour. Now it says in the question 20 centimeters cubed per hour. I'm sure it says helium. Oh yeah, it says helium leaks out. It doesn't mean helium, does it? It means gas. So whatever's in there is leaking out is the point. Now in this question, I notice it's a 10-mark question. Like, my opinion here, and my fervent opinion, is that the first 4 marks are by far the hardest. Like that's showing that. So what is the dx/dt? The dx/dt is the rate of increase of oxygen. That's what the dx/dt means. So the rate at which oxygen is increasing inside the tank. So x is the amount of oxygen in the tank at any one time. Now it's increasing by 2.5 centimeters cubed an hour. That's this here. So that's going into it, 2.5 centimeters cubed every hour. And then what's coming out is some amount of oxygen. Now the amount of oxygen that's coming out it's 20 centimeters cubed of whatever's in there at the moment. So the way I done it, I think, not 100% sure, but I think my method is slightly different to the example. But I don't know, it just doesn't seem to ring exactly the same. But anyway, I would say this. This is what I would say. I'd say, what's the proportion of oxygen in the tank? And it's, what is it? It's X is how much there is out of what amount of gas is there in the tank. Well, it's 500 to start with, and then every hour, if 50 is going in, 20 is coming out, every hour there's 30 extra centimeters cubed per hour. So there's 30 T. That's your proportion of oxygen in the tank. So it's X is how much oxygen there is out of 500 plus 30 T. centimetres cubed. So, and in that there, like, you know, some of you guys are good at doing that in that, but in that, I'm thinking to myself, after 1 hour, yeah, there's 530, after 2, there's 560, and so on. Right, okay. Yeah, but that's what it is. So how much is coming out? It's that proportion of the 20, so that times 20, that's what's coming out. So that is it then. That's the end of part A. Part A then says, what's the rate of increase? It's 2.5. Take away this x over 500 plus 30t times 20. That's what it's going up by. And that simplifies to exactly what it says in the question. So 2.5 take away 10 cancels, doesn't it? So it's 2x over 50 plus 3t, and that's part A done. Now we can then, this is an first order linear differential equation. So let's rearrange it so that it looks the part anyway. So go on, dx with dt plus 2x over 50 plus 3t equals 2.5, and then there's me derivative of the x plus py, yes, equals q. So my p in this case is 2 over 50 plus 3t. So my integrating factor, yes, is e to the integral of 2 over 50 plus 3t dt. And I'm just going to manipulate that so it looks right. I want this to be the, what's the word? To be the differential, I suppose, derivative. Differentiate that and you get that is what I want. So if I have 3 over 2, is that right? No, 2 over 3. E to the 2 over 3 times 3 over 50 plus 3t dt. And then that is e to the 2/3 log 50 plus 3t. And I like this because I've almost got an e to the log situation, and I want to do this. 50 plus 3t, my hand keeps being in the way, sorry, to the 2/3, which is 50 plus 3t to the 2/3, yes. Okay, so that's my integrating factor. So let's times everything by that. And I've got then, so 50 plus 3t to the 2/3 dx with dt. Let's do this. Plus 2x over, what is this? 50 plus 3t, I don't know why I've written over. 3t to the 1/3 anyway, equals 2, I've run out of space here. 50 plus 3t, oh, this is a joke, to the 2/3. Right, I'm going to put that in the box. Yes, sorry about that. Poor planning that. There we go. Yeah, it looks nice that now. Right, okay, so obviously we've sorted this out exactly, haven't we? So that it is a perfect differential. It's d by dt of what? Of x times 50 plus 3t to the 2 over 3. And it is, and you can check that it is, but it is, equals 2.5 times 50 plus 3t to the 2 over 3. So if we integrate both sides, I get 50 plus 3t there to the 2/3 equals, now let me integrate this then. I've got 2.5 there, and then I need to increase the power of the bracket by 1, so it's 5 over 3. Divide by the new power and divide by the 3. And I have 2.5 over 5 times 50 plus 3t to the 5 over 3. So what do I mean? I mean half, don't I? A half of 50 plus 3t to the 5 over 3 plus c. Okay, and is it worth... Not sure it's worth subbing in now. You know, I think I'm going to sub in now. Yeah, I will. Okay. To find c, I'm talking about, like, just think it's... I'm going to divide by that in a minute. But if I sub in now, then I can find c, and then... there we go. So I'm looking to see what it says. It says, oh yeah, okay, initially it's 500, isn't it? Is that what I'm saying? Oh no, initially it's naught. Yeah, there's no oxygen initially. It's just totally helium. So T is naught and X is naught. So that's nice. Better than subbing in 500 anyway. So you've got naught. That's nice there, naught. That's why I left it. Equals a half of... Now, I'm sorry about this, there's nothing you can do. You just have to leave it like that. So C is... looks disgusting, this, but that's as good as it gets, I think. For me, 5 over 3. Yeah, I think I do. Yeah, that's right anyway. So now, what is X? X, and that's what we want. We want the volume of oxygen in the tank after 4 hours. So X is a half times 50 plus 3t to the 5 over 3 minus a half of 50 to the 5 over 3 all over 50 plus 3t to the 2 over 3. And I don't really see the point in... I could simplify this, couldn't I? But then that'd still look horrible. So I'm just going to leave it like that. And then I want to sub in T is 4. Right, okay. So, subbing in T is 4. I'm just going to sub in T is 4. So that'd make this 62 and this 62. And that's it. So it is 0.5 times 62 to the 5 over 3. Take away 0.5 times 50 to the 5 over 3. Not very fast here. Over, I should have had this done and then just got it out to look boss. Over 62 to the 2 over... I'll do stuff like that in the future, that'll be better. Right, go ahead. Okay, equals... Yes, 9.3. Yeah, 9.3. I'm sure that's right. It sounds about right, doesn't it? But check that. Well, you can check that. So X equals 9.3. What's the word? Centimeters cubed when T equals 4. Okay, and then part C says explain how the model can be defined. The answer they want you to say, and you know, I've got no problem with this. It's perfectly sound to say. It's this idea of if the oxygen comes in here, like how do you know it disperses immediately? Like how do you know it all mixes, and that's it. Okay, hard question that, but really worthwhile getting good at. Okay, nice one.